Hello everybody and welcome back to another visual pattern challenge. Here's our pattern today. Here's the first step, the second step, the third step, the fourth step, and your challenge is to predict the number of squares in the fifth step. If you can do that, can you predict the number in the 43rd step? And can you write an equation that could be used to predict the number of squares in any step at all? That's the challenge. If you'd like to accept it, pause the video and work it out. Okay, so, this is interesting. I think we're going to get some pretty good intuition from how we, interpret this visually. And the reason I say that is that we've got squares here that are just jumping out at me. Squares and then something left over. Here is a 2 by 2 square. Here's a 3 by 3 square. Here's a 4 by 4 square. And I guess this then we could call a 1 by 1 square. So that just looks like a square with the side equaling the step number, right? So in step 5, we would have a 5 by 5 square, so that would be 25 squares. Now the part that's left over, well, first it's 1, then 2, then 3, then 4. It looks like it's just a row that's the step number long. So we're going to have a row of 5 right here. And I think that's it for step 5. So 25 plus 5 squares would be 30 squares. So that's my prediction for step 5, 30. So I think this is pretty clearly going to be a quadratic. And from this visual intuition, I think we can write an equation for this pretty easily. But let's just make a chart with the numbers just to verify that this should be a quadratic in case something's going wrong or I'm having a misapprehension about something. So I'm going to make a chart with the step and the squares. So in step 1, there are 2. In step 2, that's 6. In step 3, we have 12. In step 4, that's 16, that's 20. And in step 5, we're saying 30. And if we find the differences here, 6 minus 2 is 4. 12 minus 6 is 6, 20 minus 12 is 8, and 30 minus 20 is 10. So we're not getting a constant in our first set of differences. So it's not linear. That's okay, that's what we were thinking. Let's take the difference of the differences. 6 minus 4 is 2, 8 minus 6 is 2, and 10 minus 8 is 2. Aha. So this is what I was thinking. A constant in the difference of the differences means it's quadratic. So we've got an x squared in here somewhere. And that x squared just jumps out, right? It is the step number squared that is this box. So we have that part, the part I've outlined here, and then we have that row sticking out, which is always just the step number. So we could just add x. That's the step number. So our equation then would be y equals x squared plus x. I'm already writing it down here because I'm pretty confident that this is going to work out. But let's test it with a couple. So here we'd have y equals 1 squared plus 1. Yep, that would be 2. Here we have y equals 2 squared plus 2. 4 plus 2 is 6. That's right. Here we'd have y equals 3 squared plus 3. And that would be 9 plus 3 is 12. And you can see it really matches the numbers, but also really matches this visual representation of the pattern. So I think we've got our equation. And to find the number in step 43, we're just going to plug 43 in for x in that equation. So y equals 43 squared plus 43. And let's see, 43 squared is 1849, and plus another 43, that would be 1892. So I think there are 1,892 squares in the 43rd step. What do you think? Did you get that? Did you get 30 for step number 5? Let me know. Thanks, everybody.